Human beings have never ceased exploring the vast starry sky, and the emergence of rockets has become a necessary tool for us to realize our dreams. I am Claytab, who will lead you into the world of rockets today, so that you can understand the principles and applications of rockets in detail. The rocket is a launch vehicle, a propulsion device used to transport manned spacecrafts, space stations, satellites, and other spacecrafts. Before explaining the rocket explicitly, it is necessary to understand the speeds that the rocket needs to reach. To accomplish different missions, there are 3 cosmic velocities for rockets. The 3 cosmic velocities are 7.9 kilometers per second, the first cosmic velocity, 11.2 kilometers per second, also called the escape velocity, and 16.7 kilometers per second, the third cosmic velocity. Through a long period of scientific research, it is revealed that the flight speed of the rocket is determined by the ratio between jet velocity of the rocket engine and the mass of the rocket. The larger the mass ratio is, the higher the speed that the rocket can achieve, thus improvement of the jet velocity of the rocket motor becomes the key. Tests have indicated that a single-stage rocket with liquid oxygen, kerosene and others as the propellants cannot even reach the first cosmic velocity. Even with liquid hydrogen and oxygen as the propellants, the single-stage rocket can reach a jet velocity of 4.2 kilometers per second at most, which is far from the first cosmic velocity. That is because the rocket is launched on the Earth, and the air resistance also needs to be considered. After calculation, the actual velocity of the rocket should be at least 9.5 kilometers per second. In this way, the ratio shall exceed 11, which means that the propellant shall account for more than 91% of the total mass of the rocket during takeoff. In this regard, the former Soviet scientist and founder of modern astronautics and rocket theory, Tsiolkovsky, proposed the idea of using the method of multistage rocket relay to reach the cosmic velocity. When the rocket is vertically launched, the lowest stage starts to work firstly, which will be separated after completing the task. Then the upper stage starts to work to improve the velocity. In this way, the rocket's different stages work separately and always keeping forward till finally reaching the required cosmic velocity. The idea has been turned into a reality, and rockets, with multi-stage motors, can now fully meet the requirement of 3 cosmic velocities. It is not difficult to understand the propulsion principle of the rocket. Newton's classical mechanics has clearly explained that if it throws a certain mass backward at a certain speed, it will be driven by a reaction force and accelerate forward. Therefore, according to the physics theorems, the rocket motor becomes the power provider for the rocket. After the rocket motor is fired, the propellant is fully burned in the motor combustor, producing a great deal of high-pressure gas. Then the motor nozzle injects high-pressure gas at a high speed on the ground, generating a reaction force on the rocket that drives it forward in the opposite direction of the gas injection. What should be explained profoundly here is that the solid propellant is rapidly burned from the internal bottom layer to the top layer, or from the inner layer to the external layer, while the liquid propellant stores and charges the fuel and oxidizer with high-pressure gas, and then pumps the fuel and oxidizer further into the combustor. The chemical energy of the propellant can be converted into the kinetic energy of the gas in the motor, creating a high-speed airflow and a thrust. From the above, it can be understood that engine fuel is the key factor to the rocket performance. Rocket engines are divided into 2 types in terms of fuel physical forms, which are liquid propellant rocket engine and solid propellant rocket engine. Firstly, LPRE has many advantages. It has large specific impulse and high thrust-to-weight ratio, which is much higher than that of SPRE. Then, the thrust is adjustable, while it is flexible to shut down and start. Liquid propellant rocket engine can adjust the thrust and easily switch on and off engine. In addition, the fuel cost is low, and the recycling advantage is prominent. Liquid fuel costs are relatively low. For instance, kerosene and methane are cheap, much cheaper than solid fuels. Certainly, the corresponding disadvantages are also apparent, like the high research and development expenditure, the complex motor structure, a high production fee, and the high storage cost of liquid fuel. At present, solid fuels are mainly sodium borohydride, dimeric acid disocyanate, kerosene, and other derivatives. Solid fuel rockets have the following advantages. The first is the thrust of a solid fuel motor rocket is much higher than that of a liquid rocket of the same size. For example, the current 3.7-meter diameter liquid rocket with the largest thrust at sea level, the Falcon 9 of the U.S. company SpaceX, has a takeoff thrust of about 680 tons through the parallel connection of 9 engines. The solid motor with the same diameter of 3.7 meters in the United States has a thrust of 1,600 tons and is used as a booster for the heavy-lift rocket SLS. The second is the simpleness of launch. The solid fuel rocket motor can be filled with fuel at the time of production and does not need to be refueled before launch. Finally, the structure is simple. The solid rocket motor is much simpler in structure than the liquid motor, and does not require complicated internal structures. It only needs to be insulated in the solid outer casing and then pour the fuel. Of course, solid fuels also have disadvantages. First of all, the burning time is short and the specific impulse is small. The second is that the thrust is not adjustable, and the combustion is unstable. Once the solid engine is ignited, it cannot be turned off on the way, and it is difficult to adjust the thrust. This is disadvantageous for precisely controlled space launches. It requires structural adjustments to achieve adjustable thrust. The current rockets have been developed into various categories, which can be classified in different ways. First of all, according to the above, they can be divided into liquid propellant rocket engine and solid propellant rocket engine. According to the stage, they can be divided into the single-stage rocket and the multi-stage rocket. Generally, the stage number will not exceed 4. Based on the use, they can be mainly divided into the sounding rocket and the launch vehicle. Many countries around the world already have their own iconic rocket models. The United States has the famous American Delta Atlas V rocket and the latest SpaceX Falcon series. Russia has the Russian Proton and Soyuz series. China has the Chinese Long March series. Europe has the European Ariane series. After the fuel and the engine, let's talk about the overall structure of the rocket through the specific rocket model. Take the Falcon 9, which is the hottest SpaceX series now, as an example. The rocket is a 2-stage launch vehicle. The liquid oxygen kerosene engine is used, which belongs to the liquid fuel engine rocket. The first stage uses 9 Merlin engines, arranged in a circular distribution of which 8 are in the same distribution circle, and the 9th is in the center. The second stage adopts a Merlin vacuum engine. Compared with the first stage, the Merlin engine used in the second stage enlarges the nozzle to enhance the jet efficiency. The first stage is recoverable, including the first stage engine and the interstage. Depending on the payload can be launched in a fairing or a SpaceX Dragon that carries specific objects. The fairing is a 2-half cover structure with an aluminum honeycomb carbon panel sandwich structure, where the thickness of the aluminum honeycomb is about 25 mm. The Dragon spacecraft currently only provides cargo services, and there will be manned services in the future. The Dragon spacecraft can also be reused. Mentioning SpaceX, we naturally associate with its famous Starlink. The purpose of the Starlink is to deploy tens of thousands of satellites in low Earth orbit and provide quality internet services to every corner of the Earth. The program typically uses a Falcon 9 or other rocket and can launch about 60 satellites at a time. When the rocket carries the satellites to the position, the satellites loaded in the Dragon spacecraft are separated, and the satellites are then slowly deployed to their respective orbital positions. The krypton-ion propeller used by the Starlink satellite is the best helper to assist it in reaching its predetermined position and expand. Upon reaching the final position, the satellite unfolds and begins functioning. In addition, in the Starlink program, the rocket first-stage propeller recovery is a unique technology of SpaceX in the globe. At an altitude of 80 kilometers from the Earth, the Falcon 9's first stage separates from the second stage and inverts. There is an outer exothermal protection layer in the first stage. When entering the atmosphere, it inverts again. Directing the tail at the ground, it flies downward in the atmosphere at a speed of 4,800 kilometers per hour. When the motor finally opens, it goes down to 10 meters per second until it lands smoothly. The first stage propeller of the recycled rocket can be reused. At present, there are 3 ways to launch rockets, namely, land launch, air launch and sea launch, with the first one being the mainstream launching method, which is divided into inland launch and coastal launch. With the same function as the inland launch, coastal launch has a huge advantage to solve the problem of the rocket debris. The coastal launch site is on land, with at least one side facing the sea. It is because of the sea front that the problem of debris falling area can be solved properly. For example, almost all the launch sites in the United States are coastal due to its geographical location and technological strength. Its most famous Kennedy Space Center in Canaveral, Cape, Florida, is near the Atlantic Ocean. Due to its superior geographical location, it was established as a rocket test launch site in 1947. The Kennedy Space Center, the closest area to the equator in the United States, launches rockets to the east, which can use the Earth's rotation to generate an additional speed to help get satellites into the orbit. Meanwhile, facing the ocean can avoid the problem of debris impact area. Besides, in the southeast, it faces the Bahamas and the West Indies, which are suitable for a series of launch monitoring stations. The development of rockets has advanced rapidly with the changing technology, and human exploration of the universe will not stop. That's all about rockets today. I am Claytab, invite you to a more wonderful world.